Mr. Rain going on Math 5B, Quiz 11. This was on Pascal's triangle, what is a rational function, horizontal, vertical, removable holes, and graphing the rational functions. This is taken March 5th, 2020, versions E, H, and K. Question tells you multiple choice directions, circle the best answer. The is one answer. Multiple choice, which is not a rational function. But what is a rational function? A rational function, yes, it is a rational function if you have two things. Number one, they're both polynomials, which means that their exponents are whole numbers. And then you have division of polynomials. So here, you have a polynomial because it's to the power of 2. And it is division because you can put a 1 over it, and then x to the 0 power, which is 1. So this one is a rational function, but we're not looking for a rational function, we're looking for not a rational function. So E would be incorrect. We're not looking for rational functions, we're looking for not rational functions. Here, the numerator is a polynomial, and down here it's not a polynomial because remember x to the 1/2, x to the 1 power, and the denominator is the number inside the square root. This part is not a polynomial, so this is not a rational function, and we are looking for not rational function, so the answer would be F. This one, g of x, I took these directly from your skills practice packet. X to the 2/3, you have the exponent of 2, and then the index of 3. So you have the cube root of x squared, and then the minus 1's on the outside. But again, because it's 2/3, this is not a whole number there. It's not a rational function. But remember, that's what we're trying to find, not rational function. So this could be an answer. And this one has a base of a number, and then an exponent is a variable. That's bad, not a polynomial. This is called the exponential function, so it's not a rational function. And we are looking for not rational functions, so you could have had any of these choices, F, G, or H as your answer. Question number 2. Which asymptotes are determined by canceling? Canceling is our first step, so you would first factor. Can you factor it, we would say. And then the second thing is, can you cancel anything? And when you cancel it, that's called a removable hole. So B would be your correct answer. The third one was, if there's a denominator, can you set it not equal to 0? That is your vertical asymptotes. So that would be, if it was that case, and then horizontal would be comparing the degrees, top versus the bottom degree. All right, question number 3. What is the vertical asymptote? So we just said that. You're going to set the denominator not equal to 0. So here's the denominator, set it not equal to 0. Denominator is the down part of the fraction, the bottom of the fraction. Remember, when you're solving, you're using PEMDAS backwards. So this is PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction, and when you're solving, you actually go the opposite direction of PEMDAS. You go this way if you are simplifying. So here you're going to add and subtract first. 2x is not equal to 1, and then I'm going to multiply or divide, so divided by 2, x is not equal to 1/2. And that would be choice A. Now, the difference between equals and not equals, the reason why is if you put 1/2 here, 2 times 1/2 is 1. 1 minus 1 is 0. Anything divided by 0 is undefined. That's why you don't want to pick this number, but we're saying that the asymptote is at this number. Question number 4. Find the horizontal asymptote of the given function. We're going to look at the top degree and look at the bottom degree. So the top degree, the highest number, make sure it's in descending order, meaning in the exponents, the small numbers in the top right there are going down. So this would be 2, not 1. And then the bottom degree, remember, if it has no number, you're thinking to yourself in math, most of the time it's either 0 or 1. In this case, it is a 1. The reason why it is not a 0, because a property of exponents is anything to the 0 power is equal to 1. X to the first is just 1x. So you have a 1 here, and you have to put an inequality there that would be greater than. When it has on your chart 2 is greater than 1, greater than, that means you always have a vertical asymptote always at y equals 0. So that would be choice A. Question number 5. Describe the vertical asymptote and holes for the graph. So it's already factored for us. If you look at the directions above, we wrote in question number 2, it's already factored. Now, can I cancel anything? I can't cancel anything, so that means there are no holes. So if you see a problem that has holes in it, can't be A, and it can't be these two choices. Okay, we know the answer is going to be B, but let's just say you didn't know that. Now, after you cancel, then you set, is there any denominators? Because if there's a denominator, then you set it not equal to 0. Well, I have 2 of them in this case. X plus 5 is not equal to 0, and x plus 3 is not equal to 0. If I subtract, x is not equal to -5, and x is not equal to -3. So that would be choice B. You could have bubbled it in, or circle the whole thing, doesn't matter. And question number 6. Find the second term of the expression 2x plus 1 to the 7th power. So I'm going to quickly just make out a Pascal's triangle. Start with 1, and it's like water on a house, a pitched house. And then you just add these numbers. So 1 plus 2 is 3. Hopefully you put that on your formula sheet to save you some time. Adding those numbers. And just need one more. And remember, if you highlight the second row, it tells you that you just need all of these numbers as my coefficients. So let's get those in there. 1, 7, 21, 35, 35, 21, 7, and 1. And then what I'm going to do here is, this is my A and this is my B value. So A is to the left, so I'm going to start on the left. A to the 7th and go down. Remember, go all the way down to 0. The B is on the right side, and you start at 7 and go towards the left and count down. Okay, so the second term is this one right here. That's what they want to know, if you did the answer. Now, you could have worked out the whole thing, but we'll be strategic. A is 2x to the 6th power, and B value is 1 to the 1st power. Okay, I'm going to use PEMDAS to simplify here. I'm going to do exponents first, so 2 to the 6th power. 2 to the 6th power gives me 64, and then that is parentheses, exponents, and then multiplication and division, and left, right. So I'm now going to multiply by 7. 448. And then 1 times anything is just 1. Now here you have x to the 6th power. And if you look at one of our choices, that'll be choice A. So 6 multiple choice questions at 2 points apiece. This is out of 12 on the front side. Look on the back side now. Make sure to show all your work in box answers if it's not in the chart. Given the function, complete the table. F of x equals 2 over x plus 4. Vertical asymptotes, you're going to set the denominator not equal to 0. So let's do that. Here's the denominator, the down part of the fraction. So x not equals -4. The removable holes if you have to cancel anything. So can I cancel anything? The answer is none. Now remember, the temptation might be to cancel 2 and then 4 is 2 times 2. But remember, these are like a couple. They're stuck together. You can't just go and break them up and do whatever you want inside that relationship. So keep them in there. Horizontal asymptote, you're just going to look at the bottom and top degree. So let's do that. I'm going to write it down here because I have more space. Top degree, bottom, and then we had 2 over x plus to the 4. I'm going to add a couple of things in here. There is no exponent here, so this is x to the 0. And this one is to the first power. So our top degree is 0. Our first degree is here, and then the inequality I have to put in here is give me a second. Our top degree is 0. And if that's the case, you have less than. Which means that you'll have a horizontal asymptote if you look at your chart. Horizontal asymptote, let me double check this really quick. You will always have a vertical asymptote at y equals 0. I'm just checking my chart there. All right, let me give yourself a visual and then you can help figure out a table of values. Okay, so -4, 1, 2, 3, 4. I'm just going to pick a color. Let's pick blue. I'm going to mark that, -4. And then I need a horizontal, y equals 0. So it's actually on this line here. That's on a y value, that is 0. And then this could help us with our table of values, right? I'm just going to pick 2 numbers to the left of -4. So I didn't put enough boxes in here, so. But you only need 5, but I'm going to draw a bunch of them just so that I have enough, just because the students have more. -5, -6, -7, -8, I don't know. Let's see if students would ever go that far. And then 2 numbers to the right, any over there. -3, -2, -1, 0, 1, 2. And then I'm going to go ahead and punch this into my calculator. The original equation, again, use parentheses for each of those. You can put parentheses around that one. and then you put into your calculator, and then press second window. Table start at 3. I'm counting by ones. I want this to be auto and auto. If it's not, just press auto, enter, down, enter. To get to your table of values, you're going to press second graph to get to your table. There's my values, and I'm just going to go up to whatever I had, and then copy down these numbers. Negative 0.333, negative 0.4. As I'm copying down, I'm realizing that these numbers are going further away from 0. Remember, the error is the undefined. That's what U is, undefined. That's your vertical asymptote. Some more numbers over here. Negative 3, 2, negative 2, 1.667, 0.5. And you'll actually notice that a lot of the numbers mirror each other by positive negatives. Alright, so these are my table of values. Remember, you only need 5 of those, and hopefully in the middle of your table you picked that one right there. Let's go ahead and graph that. So I'm just going to graph maybe negative 5, negative 6, negative 5, and negative 3, negative 2. So negative 6, negative 1. And what you want to pay attention to is it above or below the horizontal asymptote. Negative 5, negative 2. And then undefined, negative 4. Negative 3, 2. Negative 2, 1. And I forgot to show you guys really quickly, if you wanted to pick one of these values, let's pick 0. And if you put that into your original function, I'm putting in 0 for x. 0 plus 4 is 4. 2 divided by 4 is 1/2 or 0.5. And that's how I'm getting the table of values. Okay, you're just looking for above or below. Here's a couple of hints to make sure this graph is correct. This is to the first power, that is odd. Odds will have boomerangs away from each other. If the denominator is even in regards to what's there, then you will have, we talked about that, volcanoes on the same side. Let's go ahead and graph this now. There's my graph. So make sure to use a straight edge. And then from this graph, I'm going to go ahead and do question number 10. You complete the table using the graph above. So domain, we're going to go left to right. Let's go ahead and label this negative to positive infinity on the x-axis. This one right here is the y-axis, or the f of x. And up here are positive numbers. And down here are negative numbers on the y values. So the domain is going from left to right. So I'm coming from the negative numbers, and my graph is starting, right? The arrow means it can always continue over here. So you have, the point is where is the graph? The graph is where negative numbers are. There's numbers as it goes close to -4, but the dotted line says you can't pick that number. Start over here on this side. So there you have -4 to positive infinity. I'm not worried that it's pointing up. So here's my answer. And did it again, -4. And the vertical asymptote does two things. Number one, it tells you what the values to pick. Number two, it tells you if there's only one vertical asymptote, there's going to be two graphs. 1, 2. which means you'll have 2 intervals, 1, 2. And if you notice here, it's separated by the vertical asymptote. What's the range? Range, you go from the bottom to the top. So I'm going to use my pen here. Going from negative numbers, the reason why is the arrow continues forever. So negative infinity, and then I'm going to stop there at 0, which is actually the horizontal asymptote, and then 0 towards positive infinity. U stands for union, which is you're just connecting the two. Again, the 0 here is my horizontal asymptote. And quick interval notation, for infinities, positive or negative infinity, you are always going to use the parentheses. The reason why is you can never pick a particular number in negative 10,000, negative 10,001. The parentheses means don't include. You can't pick one particular number and then negative numbers or positive numbers. If you ever have the situation where you can either a closed circle, that means just to include. So there's a different notation in interval notation. End behavior, yellow box, it's always the same. As x approaches positive infinity, so as you go towards the right, and as you go towards the left, because on the x-axis it's either right or left. We're going to look at what happens to our graph here. As x goes towards positive infinity, so on the x-axis here is infinity, so as you go towards the right, and behavior is simply just looking at the arrows here. What happens to the arrows? Is it going up, down, or just staying? And it looks like it's staying here and it's landing on the y value of not -4, but 0. So remember, you're looking at the f of x, or the y values, the y-axis, or the y number line. As x goes towards the left, so as I go towards the left of my graph, the last thing is the arrow. It's kind of landing its plane there at y equals 0. And there's your end behavior. 14 points on the back, 12 on the front, 26 plus name period. That is written neatly, and then you have added 28. Hope that was helpful. Good luck.
Math.
Say it again.
Our math.